Alright, we have a problem from the electromagnetism section of your physics book regarding electric potential section. And I'm going to read the problem. The problem will be in the description below the video if you need to read it further. So the problem is a small metal sphere carrying a net charge of Q1, which is right here, is held in a stationary position by insulating supports. A second small metal sphere with a net charge of Q2 and a mass of m is projected toward Q1. When the two spheres are 0.800 meters apart, Q2 is moving toward Q1 with a speed of 22.0 meters per second. Assume that the two spheres can be treated as point charges. You can ignore the force of gravity. And part A is what is the speed of Q2 when the spheres are 0.400 meters apart. And then part B is how close does Q2 get to Q1. So we're looking at, we want to find from this red marker here will denote Q2. We want to find from Q2 to here, where this is 0.400 meters. So we want to find the velocity at this point. What is the speed of Q2 at that point? So let's think about what we have in this problem and what we can work with in order to solve the problem. It seems maybe a little loaded if this is you're first starting to do the electric potential problems, and so we need to break it down. So first thing I did is I drew a free body diagram of the problem, and I wrote down all my given variables and everything. And I'm going to think about what equations I need to use for this problem. And so if we think about this, we have potential, we're working in electric potential, right? So we know we're going to be using the formula for electric potential. But now we have a mass and a velocity involved. And so when you see those two, or either one of them, it's probably safe to assume that we're going to have kinetic energy in here. So we're going to start off using the conservation of energy formula. And so that's going to be the kinetic energy of A plus the potential energy of A plus some work is equal to the kinetic energy of B plus the potential energy of B. And so that's the conservation of energy. And so we look at this and think about what can we solve in this equation here. What values do we have with what numbers that we have that we can actually solve? And so if you think about this here, well, first off, only the electric force does work in this situation, so we can just kick this W out of here. We don't need that anymore. So we're going to be left with just Ka plus Ua equals Kb plus Ub. And now, if you think about this here, we're looking for velocity. We're looking for, you can call it the final velocity. And so if A here is represented as your initial, then B must be your final. And so what we want to do is we want to solve for Ka, Ua, and U sub B. So we want to solve for those three so that we can plug in this equation and solve for K sub B. And so in order to do that here, let me get another sheet of paper, run and roll. Okay. Alright. So we use our, let's look at U sub A first. U sub A, this marker's going bad on me. Okay, U sub A is going to equal your Coulomb constant times Q1 times Q2 over R sub A. And so now remember, this is the potential energy, so we don't square the R and we don't take the magnitude of the charges. We leave it the way it is for potential energy. And so we have Q1 and we have Q2. That's negative 2.8 and negative 7.8 mu coulomb, so make sure that you change that to times 10 to the negative sixth for mu coulomb changes. And then we have our first radius, which is 0.800 meters apart. So that's our radius A. Call this radius A. And then we have radius B, which is going to be 0.400 meters, so we'll call that radius B. And now we can use those. So we take what we have, our Coulomb constant, both charges, and radius A, and I have the solution already. I assume you guys can plug numbers into a formula and put it in a calculator, so I'm not going to go through that part right now. And that's going to equal 0.2454 joules. And similarly, U sub B is going to be the same exact formula, and we're going to use the second radius, and so that comes out to be 0.4907 joules. And it's relatively important to put a plus sign in front of these here, or a minus sign, depending. It gives us some information later. It may not, your answers may not be messed up, but it helps. So, okay, and now we need to find K, the kinetic energy for K sub A, and so that equals, well, we all know 1/2 mass times velocity squared, and that'll be the velocity of A, and which is Q2 up here, 22 meters per second. And so we type this in, 1/2. Now our mass is in grams. We need to convert that to kilograms. So we're going to get 1.50 times 10 to the negative third kilograms. And then we multiply that by our velocity squared, 22.0 meters per second, and square it. And so that comes out to be 0.360 joules. Okay, so now we have found the K sub A, U sub A, and U sub B. And so let's use that information now to figure out the rest of the problem. So part A is, what is the speed of Q2 when the spheres are 0.4 meters apart? So, okay, so they're 0.4 meters apart. So what we want to do here is we want to take what we know now and plug it back into this equation. And what we're going to get here is we're going to get K sub B is equal to K sub A plus U sub A minus U sub B, like so. And now we know that K sub B is equal to 1/2 mass times velocity squared. And we know the values of all three of these here. We're going to get 0.3630 joules plus 0.2454 joules minus 0.4907 joules. And now we want to solve for velocity. So we add all these up together, multiply them by 2, divide them by the mass, and take the square root of them, and we end up with the velocity equaling 12.5 meters per second. So that is how you find the velocity between two charges with the given information that we were given. And so now we want to do part B for the problem. And let me go back and read part B again. Part B is, how close does Q2 get to Q1? Okay, so for part B, we want to look at the information again, what we need and what we need to find and everything. So let's see here. Let's go back to our picture here. And we've got our picture here, and now we've got essentially, it's the same diagram here, and in this situation we're going to say the velocity here, I'll call it velocity sub z, and that's equal to 0, and so we'll call this point here is C, and this point here is A. And so this is Q2 again, and it's moving over here to Q2. Hope you can see that okay. And so we've got that. So we're going from points. Let me get another piece of paper. Okay, so we're going from, we have points A and C here, and we need to find out how close, let me read the question again here. How close does Q2 get to Q1? Okay, and so in order to solve that, we're going to take some of the information that we have from the previous part of the problem, part A, and we're going to take K sub A and write that out, and we'll take U sub A and write that out. And notice how I'm only taking the A parts, and that's because our point here was A, and our new point is denoted as C, and so we're not going to be using U sub B in this part. So we've got these two answers here, and we're looking for, we need to find U sub C, and we know the equation for that is Coulomb's constant times Q1 times Q2 divided by the radius of C, and we get the conservation of energy in this case is going to be equal to K sub A plus U sub A is going to be equal to U sub C, and we add those together and we get 0.6084 joules. And now we're solving for distance, and so, but let me point out here, if you're wondering why there's no K sub C here, there was a K sub C, but since we know that the velocity equals 0 at this point, that the kinetic energy is equal to 0, if you didn't catch that part. And okay, so now we've got our potential energy C, and we know what Q1 is and what Q2 is, and we're looking for the distance r. So we can take this equation here, and we can say r sub C is equal to the K over U sub C times Q1 and Q2. And so we take this for our U, we've got our two charges up here, and we know our Coulomb's constant, and so we do that, and we get the radius to equal 0.323 meters. And so that is how you work that problem. That one's a little lengthy, a lot of opportunity for error in that. And so hope that helps, and remember to subscribe, because I'll be putting a whole bunch of these videos out and you'll be notified when they're out. And also, if you subscribe, you can submit me a problem and I will do it for you and make a video for you if you can't find it. Alright, thank you.